What is epistasis? When one gene locus masks or modifies the phenotype of a second gene locus. Different genotypes can lead to the same phenotype. This is a cause and effect relationship that can be shown as a precursor, an intermediate, and then a final pigment. Let's think about making popsicles. The precursor is the popsicle ingredients, the intermediate is the making of the popsicles, the pigment is the final product of the popsicles. So you go to the store to get the liquid mix, the ice trays, and popsicle sticks. However, you get home to make the popsicles and you realize you don't have power, which you need to freeze the popsicles. The power could be masked through epistasis. So, although you have the liquid mix, the ice tray, and the popsicle sticks, without the power, you won't get the final phenotype or the popsicle sticks. Not being able to freeze the popsicle sticks would be considered a mutation. This could also result in a modified phenotype of a slushy-like popsicle if the freezer just isn't working as well as it should, which can happen if a gene isn't fully being masked, like in codominance. So the power being out is just one way we can't make it to our final product. Not having a freezer could be a different way that you're prevented to getting to the final product. This is the same in epistasis. There are many different ways and different types of epistasis. So, when being asked to cross these two genotypes, well, there is a duplicated recessive epistasis, which is when a homozygous recessive allele in a genotype masks any dominant alleles in the genotype. So anything with little a, or little b, will have the same phenotype no matter the other alleles. So this can be seen here. Two traits cross two phenotypes with 16 squares. This one is crossing two heterozygous genotypes, and over here you are crossing two genotypes with one heterozygous allele and one homozygous allele in both genotypes. There. Because of the dominant big B allele over here, there's no chance for little b masking the other allele in this Punnett square. So that makes there to be a 50-50 chance of the phenotypes. Well, over here, it crosses two genotypes with both heterozygous alleles, which allows for a 9-to-7 ratio of the 16 with the two phenotypes. Here I have highlighted the 9-to-7 ratio that you see in the duplicated recessive epistasis. There is also more ratios for other types of epistasis that can occur, like single recessive and single dominant, or duplicate dominant epistasis.